Alright troops, Yoker Uni presents Glasgow Physics!
Whoop whoop, that's the sound of the police. Valdo here to teach you some more wonders of the universe, or physics as we like to call it. If you were in Glasgow in June time there, you will have witnessed an annual phenomenon which lasts for about a week and sends the city pure tonto. It's called summer. In Glasgow, summer's the wee bit in between the spring rain and the autumn rain. Summers in Glasgow, though, aren't the prettiest in the world. It usually means all the pure stank monsters and jakies surface and hink their own Miami Beach, even though they're waiting for a taxi at Asda Clydebank with their 8 bags of alcohol, smart price burgers and rolls and a party-sized disposable barbecue. A typical summer BBQ in Glasgow usually ends up with food poisoning, a fight with your next door neighbour, and somebody getting papped in the jail overnight. As for sun soaking, flesh colour in Glasgow is either peely wally pasty white or red raw like a scalp bahookie. In Glasgow, people actually use sunblock with a negative SPF number. Only in Glasgow does Boots the Chemist sell crisp and dry cooking oil. People just aren't happy with their skin colour, because in a Glasgow summer you get the pure Oompa Loompa fake tanners driving their birthday wee motors with the roof down at the slightest glimmer of sunshine, pure hinking the Tesco car park at Silverburn's Casino Square, Monte Carlo. Put your roof up, you look like a dafty. Yeah, dafty. See, fake tan, I've actually got a theory called Valdo's Law, which pure states that as fake tan increases, intelligence decreases. Fake tan is pure bouffing, man. It smells like somebody's pure mixed digestive biscuits with sour cream, and then papped in a wee dog's jobby for good measure. It is rank. All this nostalgic talk of summer got me thinking about something that people don't really understand. They get pureconfused.com. My brain's here to help you out. It's all to do with heat. We know it makes Glasgow go mental, but what actually is heat? Let's find out then. Right, heat and temperature are actual two different things. Temperature tells us how hot or cold something is, or how much heat energy something has. Temperature of a substance really means how much average kinetic energy, or movement energy, or the wee mad particles of the substance has. Or if you don't speak like a pure bottom, the particles that make up a substance move faster if it's got a higher temperature. Here's a wee simulation Mad Smudge made up on his Commodore Amiga 500 to show you what particles that make up a substance look like when their temperature goes up. Remember, the wee balls are supposed to be atoms, and the size of an atom goes something like football, golf ball, molecule atom, Deco's brain. Right, there are actual 3 different scales to measure temperature. There's the Fahrenheit scale, which is crap. Only Americans use it because they're a bit weird that way. Sometimes though you get a wee granny or grandpa in Glasgow who still use it, but they're just being stubborn buggers. The kind of people who think computers are witchcraft, and to double cut your mouse summons Beelzebub himself. Proper members of the human race use the Celsius scale, which is water freezing at 0 degrees and boiling water at 100 degrees. It was the centigrade scale for years, but the little wee Andy Celsius geez named it, cause even though the silly bottom had the scale the wrong way round, he kinda did figure it out though. The last one's the scale that us pure physicists use, cause its starting point is 0 Kelvin, which is absolute zero. Kelvin comes from the guy who gave his name to the scale, Billy Thompson, who was some mad baron of Kelvin or something like that. We don't use degrees Kelvin, just Kelvin. And 1 degree Celsius is the same size as 1 Kelvin. Capiche? It's all fair enough talking about the particles moving faster as your temp goes up, but what else do you need to know? Well, here's a wee thinker for you. Take a bit of metal and a bit of wood the same size and shape and that. Pat them on your table and leave them for about 5 minutes. See, when you go back to touch them, why is the metal one colder than the wood? They're both at the same temperature, so the wee atoms and crap move at the same speed. Thing is though, when you go to touch it, your body temperature is pure higher than the wood or the metal. What happens is there's a pure flow of heat energy from you to the metal or the wood, In other words, heat is leaving your body through your fingers, and this is how things feel cold. Metal takes away heat for you quicker than wood, so it feels a bit colder than the wood. What about if you pure touched a kettle that's boiled? The kettle's well hotter than you, so when you touch it, and I recommend that you don't, heat energy for the hotter kettle goes into your fingers and it'll be burny. If heat energy leaves your body, it'll feel cold. If heat energy enters your body, it'll feel warm. That's how it's pure hard to stay cool in the hot sunshine, cause your body doesn't transfer heat as quick to the air around you, cause it's almost at the same temperature as you. Right, I'm going to have to get pure scientific with you here, cause all this heat transfer crap needs clearing up. Some people were pure getting heavy confused with this heat, so some brainy bottins pure made up 3 laws to explain how heat can be transferred and that. They are called the 3 laws of thermodynamics. Law number 1 pure says that energy can be created or destroyed. All the energy we've got in the universe is we're whack. All we can do is pure change it about. Heat energy off a fire isn't pure abracadabra due to nothing. We need to take the chemical energy stored in some fuel like coal or wood and pure burn it so it changes into heat energy. Law number 2, and this one is depression. It says that all the energy which is stored up in a concentrated place will naturally spread about. Think about burning a candle and all the chemical energy concentrated in the wax is pure transferred as heat to the air in the room and spread out to the rest of the world. You can't get all that back to one place again without using up more energy for somewhere. So in other words, we'll use up all our energy and not get it back. We're all gonna die. The world will fall apart. The sun will stop burning and the universe will end. And there's bugger all you can do about it. Never mind the big chap, can't be helped. Law number 3, this one's pure mental. Remember I said that the temperature of an object tells us how fast the particles that make it up pure fire about MWI. Well, it turns out that there's a temperature when the particles stop moving, and this is called absolute zero. Turns out though this temperature is physically impossible. Like I said before, this is actual 0 Kelvin. It's also minus 273.15 degrees Celsius, but we say minus 273 because we're no fussy here in Yoka. You'd be long dead when it's that cold to worry about wee decimal numbers, so don't worry about it. This also means that water freezes at 273 Kelvin and boils at 373 Kelvin. But something wasn't right though. They realised there was a 4th law of thermodynamics that was actual more fundamental and more important than the other 3. They were pure saying, oh no, crap man, what are we going to do? We can't call it number 4 because it's more important. Well, it turns out they didn't want to start rewriting all their textbooks because that would use a hefty amount of Tipex. Other corrective fluids are available. They pure went and called this law the 0th law. What a stupid name. Law number 0 says that if you pop a hot object next to a cold one, then as long as no more energy gets in or out, the hot one transfers heat to the cold one until both objects have the same temperature. That's why your cup of tea gets colder, because it heats the air around it until both the air and the tea are the same temp. That's also why your ice cream melts, because the hotter air gives the ice cream heat until they're both at the same temp. These laws are actual dead easy. So if you burn yourself when you touch something heavy hot like oil on a deep fat fryer, it's because a lot of energy is transferred to your body very quickly. Does that mean then if you touch something pure heavy cold like liquid nitrogen, then since a lot of heat energy leaves your body, could you still burn yourself? There's a wee one to think about. Catch you Versace, enjoy your summer.